166. So in this chapter, we are going to continue our discussion about triangles. But there are some strange things we're going to learn about triangles. Just throwing that out there. Okay. Lots of vocabulary in this one. Okay. So we're just going to take it step by step. I want you to understand that we will have a quiz on Friday. Okay. And then, I think our test comes up pretty quickly. Our test would be next Friday. Okay. Yeah.
Wait, do we get any days off because of the new Penta next week?
There are no days off.
When does Penta end?
The 30th.
When's that?
Like Tuesday?
No.
What were you meaning by that?
No, next week.
I don't know because
I don't
like
wanna have
sometimes like Wednesday we have full break right after.
Okay, that was just a coincidence. All right, who can tell me what equidistant means?
Equal distance.
I agree.
I can't believe you guys think you did that.
That's not like
Equal
you
distance. Okay. We are the same distance from something. So I'm going to draw a picture.
How do you spell equal?
E-Q-U-A-L.
Just do the sign.
There's no I.
I said E-Q-U-A.
Okay. All right. Somebody use equidistance in a sentence talking about this picture. Clark?
A is equal distance to B as C is to B.
Okay. Shorter sentence.
AB is equal distance to C to B, C, C,
B
B.
is the midpoint base.
Okay. So B is
The same
equidistant
A-
to A and C.
Oh, man.
Oh.
Yeah.
Good word. Okay.
I
Okay.
just said it way too long.
Yes. You probably not like that, but
She's wearing triangle earrings, guys.
I am. Because we're doing triangles.
Springer would grade them really first.
Okay.
They're all 60 degrees.
Perpendicular bisector. Perpendicular means 90 degrees. Bisector.
Bisecting.
Two equal parts.
Okay. So a bisector, if we're talking about like a segment bisector, it is cutting the segment into two equal parts. Okay. How about this one? If a point lies on a perpendicular bisector, then it is equidistant from the endpoints of the segment.
Also, C is equal distance to A.
Oh, is that what that means?
Yes.
Okay.
So those lines are.
CP is the bisector of A.
Arrow. Perfect.
Okay. So yeah, we can mark this up right here. So first of all, let's talk about this CP line. Okay. CP is a perpendicular bisector of this segment AB. Okay. We have a 90-degree angle and it's going through the midpoint. So any point I make on this red line is going to be equidistant from those endpoints A and B. Okay. Let me draw a picture here.
Well, what if you put B out a little further?
Oh, B can't be out a little bit further because then it's not a bisector.
Oh.
Okay, so here I have a perpendicular bisector, right?
Yes.
Here I have a perpendicular bisector. So I could put a point right here. And when I connect them to those endpoints, I know those segments have to be equal. Okay, now I could make a point out here. And when I connect them to those endpoints, I know that they have to be equal. No matter what point, I could draw a point over here. No matter what point I make on that perpendicular bisector line, when we connect them to those endpoints, we're going to have congruent segments. That's what this theorem is saying. Kind of beautiful.
Mhm.
I know you feel that one. Okay. Yeah, we can make a really cool picture. All right, but I do want you to draw.
Yeah, that's our homework.
So tomorrow's a weird day because we have map testing.
It's some other math.
Yeah, it is.
Trail.
I always like red wings.
Okay, draw this picture.
You don't see because you don't.
Wait, do they use this for like ninth grade?
Yeah, do they use math testing? For like ninth grade?
Would you grade it?
Do they use that in Virginia?
Will they
Brandon,
take you
they take your
down?
past scores from anywhere. I'm pretty sure they took your.
They didn't
previous
take my-
scores.
No, they didn't. It's just that I took pre-algebra in sixth grade. So I had to take pre-algebra. Yeah, but honestly, then I will actually be.
Okay,
I don't want to stay early.
what is one thing you can tell me about this picture that's not labeled? Harvey.
CD is 27.
CD is 27. Yes.
I agree.
I agree.
So how long is BG?
Well, we don't know.
Yeah.
We would have to know a little bit more. If we knew the these two segments, we could use Pythagorean theorem to figure it out, but we don't know the length of these two segments.
Well,
Technically, we haven't really been taught.
why don't you multiply?
We were very lightly taught in seventh grade. And I do not remember it at all.
The Pythagorean theorem,
A squared plus B
we've
squared
already
equals
done
C
it in here.
I did like.
We did?
Yeah.
Well, then I completely forgot about it. But I know it's
Okay,
A squared plus B squared.
now in chapter 9,
Which is in 2 chapters.
Well, yeah.
No, wait.
We already did 8.
we will get more tools about right triangles. Those buttons on your calculator, sine, cosine, and tangent, that's what we'll get to do in, not on that calculator. Okay, one more picture.
Now we go into calculation. That's on my bucket. Never could probably.
What's on your bucket list?
Learning the Pythagorean theorem more.
So intriguing.
That's so intriguing.
Okay, next picture.
Oh, it's 2x. I wrote 22.
Yeah, please stop it.
Oh, I know how to do this.
All right, Sam, how do we do it?
So 3x minus 8 equals 2x. And then you subtract 2x. And then you have, wait,
No, I add 8.
No, you add a,
Yes, X equals eight.
wait,
Just add 8 to the other side.
6.
no, see, I did it right.
Yeah, come on, you're right.
So there are two different ways you could solve this equation. You could subtract 3x and have -8 equal -x, which means x equals 8. Or you can do it like this.
I like this.
Both ways. Oh, you do you, Sam. Okay. Now, we also have the converse to this. Okay? If a point is equidistant from the ends of the segment. So let's talk about like this D right here. We know that D is equidistant to A and B because it's marked. Do you see that?
Yeah.
If that's true, then we know that D lies on the perpendicular bisector. Without having it drawn in, we know the perpendicular bisector is going to go through it.
Wait, but don't we have to know that this is from A to P and P to B?
No, because A is B.
If they don't go out the same distance, they most likely won't be able to.
So the whole point of the blue line is that it's a perpendicular bisector.
Oh, yeah, and.
To the bisector line.
Bisector without two.
So let me give you a scenario in which we would be able to use this, okay? So I'm going to draw a triangle. Ooh, that looked okay.
When do you start using Photoshop?
At the bottom.
I have one.
Did you?
Yeah. I bought
Okay.
it.
Well, maybe I'll try to find something.
Is that the thing where like, you do this?
I bought like a bunch of.
Oh, I have that too, but then
Yeah,
my
it's not
teacher
more
said I
than
couldn't have it. 'Cause it's like, oh, it's like-
This is where you draw stuff.
Okay, what is something that we can know about this picture that's not labeled? Sam?
That line right there equals 5.
Oh, I probably should have given that a, how about I call this Q?
PQ equals 5.
PQ equals 5. Okay, let's talk about how we know that. We know that P S is equidistant to P and R, which means S has to lie on the perpendicular bisector. So these two segments have to be the same. Okay. All right, so that's theorem number 1. I mean, those two kind of go together. Technically, there's 2 of them, but one concept there, right? Okay, let's go to concept number 2. Next page. Angle bisector. Woohoo! Love me some angle bisectors. Okay, so angle bisector means we have a line or a ray cutting our angle in half, right?
Yeah.
Okay. If a point lies on the angle, on the bisector of an angle, then it is equidistant from the 2 sides of the angle. What does that mean? Okay. So here is D. D is lying on the angle bisector. Okay. So what this is saying is that, you know, since AD is the angle bisector, then these 2 segments right here are congruent. They're equidistant. Now, why is there a right angle?
that means.
That's a right. C equals B.
Maybe.
So if I'm gonna measure how far I am from here to purple table, am I going to measure from me to Braden? Am I gonna measure from, oh,
Perpendicular.
I'm gonna measure distance at a perpendicular fashion, okay? So if I'm measuring equidistant, then we're talking about, so, because we're equidistant from these purple rays. Okay, if I am a point and I'm measuring distance to a line, it needs to be perpendicular, okay? But the big thing is, here's our angle bisector. Those segments right there are the ones that are congruent, okay? So let's draw a picture. Are you ready? Okay, so we have an angle bisector. There we go. There's your picture. Okay, so in this picture, how do we solve for x?
4x equals 2x.
Okay, angle bisector theorem is going to tell us that x equals, okay, what would be the measure of JM and ML?
24.
Yes. So then we're also going to have the converse, okay? Let's say we have this awesome little picture here. Well, then that means that this guy is an angle bisector. All right, so it's going to go both ways. Okay. So I'm going to draw a picture. I would like you to draw this picture. Oh, thank you. Okay, so in this picture, what do we know about the measure of angle ABC? It's 112. Nora, how did Alexa get 112? Okay, we know that since these two are congruent with the marking of, okay, we're equidistant from our sides, we know that these two angles are the same. So if this is 56, this is 56, we got 112. Okay. All right, what I'd like you to do is open up your packets to page 1. Page 1 should look like this. Nope, not page 1. Page 3 should look like this.
Figured it out. In total on this calculator, there are
Yep.
124 buttons.
Oh, cool. I'm so glad you found that out. So do you notice on page 3 where the top half and the bottom half are the same? You don't need to do all of it. What I want you to do before I give you your homework is just do the top half. Okay, so do number 1 and do number 2, but only one time. Okay. All right. I would encourage you to use the power of collaboration. Means, hey, talk to your elbow partner about how you're setting these up. I'll give you about 3 minutes.
Wait, so do you like? Equal the sides?
Y
together?
equals
Because, like,
7.
if it is a thing, then they should be. So,
Maybe all equal distance.
So yeah, you just equal
That's equal to
because-
that and that's equal to that.
X
assuming
equals
that-
4.
Yeah, okay, that's what.
44 minus 7.
4 markers in here yesterday.
37. ML equals 37.
So
MN equals 37.
Y equals 7.
Oh,
Y equals 7.
70 divided by 5. And 14. X equals 14. Y equals 10. Equals 19. Equals 19.
you're very limited collaboration going on here.
My brother have it.
For the first one, just MN equals 30. Never mind.
Mhm.
37.
Me and Bro will lock.
Oh.
Yes. I think we're like 8 at the end of this.
Sometimes you miss the sort of,
I missed the serve once.
I missed your serve once too.
I never miss a serve.
Badminton.
That,
How do you serve?
he calls me if you have badminton, yet sometimes I hit a lot.
I want to trust you. Almost all. Yes, but like sometimes. it
Why
is
would you
really
rather play with
stop.
Hayden?
Me and Kaden won
Hayden.
everything. I don't know.
We only let him
play
play
7
7
Are we done?
Yeah.
Maybe.
If you find out he was better.
Okay, Presley, in number 1, how did you set up to find X? Okay, awesome. Harvey, what did you get for X? Which means MN is what? 37 question mark?
I agree.
Okay. Oh, you just kind of had a. Harvey, with confidence, what's LM?
37.
There we go. Okay. Alex, how do we solve to find Y? Nora, what is y equal? Great. Okay, Brayden, in number 2, how do we find x? Okay, so Alexa, what does x equal? Okay, Clark, how do we set up to find y?
To find y, we set 3y minus 11 equal to y plus 9, because of the angle bisector.
Great.
It is.
Yeah.
Nobody stopped me. Okay, Ben, what's y? Okay. So then that makes segment AD and CD equal to?
I got 19.
I highly disagree. Yeah, and I got 19. So if y is 10. Okay, so your homework, which you can get a head start on, is page 1 and 2. I think